Oh, sorry, I didn't see you there. So I have this really dumb idea. This is the ABC Switch 2. It is one of my older high school projects, which I've already somewhat shown in a video 2 years ago. Except back then, it did not have this super cool 3D printed case. Essentially, it is an ESP32 microcontroller tied to a small color display, an SD card, a few inputs, and a piezo buzzer. The ESP32 can run between 80 MHz and 240 MHz and has about 500 kilobytes of RAM, though this chip here has additional 2 megabytes of external slower SPI RAM, which will definitely come in handy. I've already made some software for it, like this Pac-Man clone, but most of the stuff here hasn't changed. You can watch that old video for more info. What I'd like to do now is to get the SFML library, which targets your standard desktop and mobile platforms, to work with this. And after that, I'd like to run one of my several games made in SFML on this microcontroller. My pick is Chain Reaction 2 since it is already very portable. It has many features that are optional, like audio or shaders. Now, SFML's graphics require either the OpenGL 1.1 or the OpenGL ES 1.0 API, which usually communicate with the GPU, which then renders stuff onto the screen. Here, of course, we don't have a GPU. So what is my end goal here? Well, I'd like to write an OpenGL ES 1.0 driver that might be able to do some software rendering to get a desktop app to run on this. There are so many things why that is a bad idea, so definitely don't try this at home. There's a good reason why probably there aren't any good search results that come up on Google if you Google something like that. So this will have to be divided into several steps. I'd like to port the whole SFML library, or at least parts of it. I'll forget about audio. There's no way I'm getting that to work. Networking, for now, let's not focus on networking, just on the SFML system, window, and graphics modules, for which I'll need to look up how can I replace SFML's OpenGL, which I think it uses GLAD. So I'll have to replace that, and also I'm planning to use EGL. I think that would be the simplest solution without having to rewrite too much of SFML's code. I'd like to have to rewrite the least possible amount of SFML code and just have my own backend that will then use the display of this. Honestly, I'm gonna say this right now, if I manage to get more than 1 frame per minute, I'd be happy with that. I'm not expecting a lot at all, especially considering that the Pac-Man minigame that I made, that I showed off earlier, I mean, it is running at 80 megahertz, and yeah, it's not doing a whole bunch, but the CPU is completely, like, I think 95% or something. My goal is 1 minute per frame, or 1 frame per minute. The same thing. I'll start off with writing just a few header files or CPP files that will implement the basic functionality of OpenGL. And then once I get that to work, I'll probably ask ChatGPT to write some simple OpenGL program to test things out. Once that is done, then I can get to the complex task of actually porting SFML over to this. That will be fun, if nothing else. I hope, at least. Anyways, I'll see you when something interesting happens, when I have something to show off. So yeah, until then, jump cut. Alright, so it's been a few hours, more like 10, but anyways, I've done a few things. I don't have anything special to show off, other than that I have a successfully compiled, half-baked unimplemented version of SFML. So what does that mean? I first used GLAD to generate all of the functions. The GLAD multi-language vulkan/gl/gles/egl and so on generator. This is GLAD that SFML uses, and I basically just used it for it to spit out all of the functions that OpenGL ES and EGL use. So these would be all of the functions that I would need to implement manually. And it turned out to be quite a large number, more than I expected originally. So OpenGL ES 1.0 has in total 144 functions, and EGL has 44, so for a combined total of 188. So essentially I copied all of the defines that are needed for OpenGL and all of those functions. I created all of them, so there's like I think 600 lines of code that basically all it does is return false or and print out like the function name is not implemented. Thankfully that was very easy thanks to CLion, which can generate a whole bunch of stuff. Anyway, since there are so many functions, instead of implementing them all first and then trying to port SFML over to the microcontroller, why not first port SFML to microcontroller and then see all of the functions that SFML uses, because I'm sure it's probably like 60-70% and not all of them, which would save a lot of time and a lot of headaches, because at some point there will need to be a lot of math and that will be complicated. So porting SFML, thankfully SFML uses CMake, so it shouldn't be that difficult. Right, so I know some parts of SFML behind the scenes when it comes to CMake. The ESP32 CMake is a bit different. So I first tried to integrate CMake normally into all of the CMake lists and so on. But eventually it turns out that it might be just easier to call one function which just specifies all of the files to compile and then use that. So that is what I'm currently doing. And why not, let's switch to the monitor actually. So here we have the EGL CPP file and header file. So on the left is the header file, which has all of the hash defines and the functions. And on the right we have all of the unimplemented functions so that the compiler doesn't complain. But yeah, all of these, or at least some of them, most of them, will need to actually do something and not return false and report an error. The same goes for GLES, which has even more functions, as you can see here, and even more defines. And down at the bottom here you can see some SFML stuff. So these are the extensions and stuff that SFML requires from GLAD that GLAD generates. So this is not standard, I guess, OpenGL stuff. The point where I'm at is I can essentially do something like this. So this has successfully compiled, and this has some basic SFML code, which just creates a window. This, of course, doesn't do anything still. Generally, the system, window, and graphics modules work, at least when it comes to compiling. Now, one thing that I have not mentioned here is FreeType. So SFML uses FreeType, which is a font library. And let's just say I forgot that porting SFML means I'll have to port FreeType as well. So currently I'm just skipping that. Over here, when I specify all of the files that need to be compiled, I'm skipping over the font and the text classes. So yeah, eventually, yeah, this as well will need to be uncommented and implemented, and that is a whole nother can of worms that I'm not planning to do, not today, not tomorrow, at some point. One thing that I haven't mentioned yet is how do I plan to deal with memory constraints on this, as I don't have megabytes and megabytes of VRAM in my GPU. In fact, there is no GPU. As I mentioned from that previous video a while back, that ESP32 was actually a different model than this. That was an ESP32 generic, and this is the ESP32S3. The difference being apparently this one has some more hardware acceleration for multiplication and stuff. Maybe I'll be able to use that. I have no idea how to do that though. And this one also has SPI RAM that is slower than the regular RAM. But you know, when the total size of your RAM is like 500 kilobytes, every bit counts. So in total, I've got extra 2 megabytes of SPI RAM. The plan is to store textures and stuff over there, and then cache and I guess smaller-ish variables that will need to be accessed more frequently into regular RAM. Your typical SFML game also uses definitely more than 2 megabytes of RAM, and Chain Reaction 2, which is the project I'm eventually planning to port over to this, no matter how slow it is, uses much more than 2 megabytes of VRAM. So the plan is to downsample all of the images for them to be able to fit into RAM. Downsampling should be fine since the resolution of this display is 160 by 120, so I don't think that downsampling the image by like a factor of 4 will have much visible difference. Anyways, I'm quite tired now, and I think this is a good spot for a break. Tomorrow will be fun. What is the plan for tomorrow? The plan for tomorrow, I think, is to just straight up start implementing EGL and GL ES functions. I'll try to implement the bare basics so that I can, I don't know, just create a circle shape or something in SFML and draw that, which still requires like triangle rasterization and a lot of stuff. I think the sooner I'll be able to test on a physical device, the better, because there will be bugs, I'm sure. I've never written an OpenGL driver. I've never written a graphics driver at all, ever. Yeah, also I haven't mentioned, other than textures, the frame buffer. I'm not sure where I'm gonna put it actually. So SFML does not use the depth buffer, so I think I can just straight up ignore that, and neither does my game. Stencil buffer will be used, so that will be a requirement. Stencil buffer is like half the size of the frame buffer, because frame buffer is 16 bits, because this has 2 to the power of 16 colors. I don't know, that'll be interesting, but that is a problem for tomorrow. So yeah, see you then. So I got to the point where I can actually show off something. This. So what you're seeing here is basically an SFML window, I guess, and just clearing the whole screen twice per second in random colors. I'll show the code that does that on screen. It's entirely SFML code, which is nice. So the next step, the next major step, I guess, would be to add rasterization of triangles and stuff. Or first of all, I guess I can add just rasterization, but everything is points, no matter what primitive type you set, just for testing at first. But yeah, eventually I'll have to find an efficient algorithm that will do the triangle rasterization, and for all of the texture coordinates and the color. You know how when vertices have different colors in a triangle, you have that gradient in between. I'll have to find some algorithm that does that relatively efficiently. And then eventually, I guess I can add some more optimizations for specific test cases. If triangles aren't rotated in any special way, then that will obviously be faster to render. I hope, at least. I'm not sure what lies ahead, but for now it's quite fun just adding a bunch of functions. Okay, so I have a few things to showcase to end off the day. So over here you can see a circle going across the screen, hopefully. So this is essentially an SFML circle shape with 100 points, and it's just rotating around its origin, which is set to be in the top left corner. Currently, all primitive types are being drawn as points, which is just for performance reasons. Immediately when I actually add the triangle rasterization, that will slow things down probably 10, 20 times. I don't know. There'll have to be a lot of pixels and a lot of calculations, and currently this 100 dot or 101 point circle shape takes about 900 microseconds, so about a millisecond to render, just to render. So everything else, the refreshing the display, clearing the frame buffer, calculating the rotation matrices, that is not included. So just drawing it is 900 microseconds, which is a lot. So, and it's only going to get worse from here. I haven't implemented blend modes, I haven't implemented stencil buffers, and so on. Textures are still not implemented fully. A lot of things are missing, and I'll continue to implement stuff as the time goes on. But this is a nice breakpoint to show off essentially the best performance from this point on. Another thing that I can show as a demo is this animation. So that is usually the starting animation of my apps, since it uses only the stuff that I've implemented so far, so essentially just vertex positions, everything is colored as white. I thought, why not, let's port this over. It works really nicely. So yeah, that is all for today. It's 3 a.m, so I should go catch some sleep. So yeah, that is all for today. Tomorrow I'll continue with the triangle rasterization. That'll be interesting, and yeah, see you then. So I've implemented triangle rasterization. As you can see here, there is a triangle strip to showcase the multicolored vertices, and also a circle shape with an outline. So it took a bit of time. I had a few bugs. I'll showcase one of them I recorded on the screen. This actually turned out to be more performant than I initially thought. So these two objects that cover a large portion of the screen take both around 24 milliseconds to render when they are both on the screen. When the circle goes off screen, then it's more about 7.5 milliseconds. So yeah, that is more performance than I thought I would get. This is also with the ESP32 running at 80 megahertz. It can go up to 200. It can go up to 240. It roughly doubles the speed, which is nice. So yeah, in the end, I'll use that for most performance, but for now 80 megahertz is good enough. I've also done some basic optimizations. I'm sure there are more things I can do that I'm currently not aware of, but yeah, step by step. The next big step would be adding textures. Now this is going to be interesting because I'll actually have to start using the SPI RAM I mentioned some time ago. And hopefully, I'm not sure what is the default location, what SFML would currently use if I were to use like a file input stream. I'm not sure, is it using, I haven't told it in any way to use the SD cards, so I'm not sure what would happen. Would it just crash or something else? So yeah, I have to figure out how to load these textures. I have the vertices set up currently so that I can relatively easily use texture coordinates, and that should work fine. After that, I'll need to add blend modes, stencil buffers, and probably vertex buffers. I'm not sure if I'll use them. Currently, I've set them to be disabled. So yeah, I'll see about that. This is quite fun. So yeah, anyways, there's still a lot of stuff that I have to do. If I encounter any more cool bugs or something, something interesting, I'll be sure to record it. And yeah, see you, I don't know, in a few hours, I guess. So I've implemented textures. They work really nicely. And the performance is quite decent, I guess. I've done a bit of performance testing and I've found a few weird quirks. So it turns out that ESP32 is really slow at floating point division. From what I've read online, it's about 50 times slower to do a floating point division than it is to do a multiplication. I had a few floating point divisions with a constant number in my code, and it turns out GCC won't replace that with a multiplication, so I guess it isn't familiar with the fact that ESP32 is slow at division. So yeah, eventually I swapped that division by 255 in my case with a multiplication of 1 over 255, which I calculated in advance. And that sped up the program by 20%, which is not negligible. Currently also textures are stored in SPI RAM, and I've tested what happens if I put it in internal RAM and what happens when I put the frame buffer into SPI RAM, which has up to this point been in internal RAM. And there are some shady things going on here. So putting the texture in either internal RAM or SPI RAM has no effect whatsoever, or I couldn't notice any pattern. Putting the frame buffer into SPI RAM caused about a 10% performance loss. So the plan is to keep the frame buffer in the internal RAM and the textures and vertex buffers in the SPI RAM. I also did some benchmarking on how long it takes to copy the frame buffer onto the display. And it is about 10 milliseconds every time, no matter what you do. So I think maybe I might do a multi-threading optimization here. Since I have double buffers, I have enough RAM for that. I can just use the main core to render and do the whole game loop, while the second core is copying over the other frame buffer onto the display. This would, I guess, increase the frame rate by a bit, but yeah, theoretically you cannot go over 100 frames per second because it's physically impossible since 10 milliseconds is required to copy the whole frame buffer. That's mostly it for now. There are still things unimplemented, like the blend modes and stencil buffers, which I'm not sure if I'll do that tomorrow, or will I try to port FreeType? I think that is more fun than implementing blend modes. So yeah, that is everything for now. Let's try to do a jump cut here. That was probably really bad because I just realized I'm wearing a different shirt and probably the camera is not in the same place it was yesterday. So what is new? Not much actually. So I tried to port over FreeType. I found out that there's actually a more official-ish port of FreeType already out there. So I tried to use that, and no, don't do that. So at first I couldn't even get the example to work, which threw some null pointer dereference errors. Eventually I got it to work, and I also figured out that FreeType does not seem to like reading stuff from the SD card, but only from the flash memory. I'm not sure why. That wouldn't be that big of an issue since I can just load the whole font into RAM, hopefully, or copy it from the SD card into internal flash. So that way that would work. If that could work, but currently, unfortunately, there is something with heap not being in the correct address space or something like that. It's like 10 functions deep, so I haven't researched much as to why that happens. And neither do I know FreeType. Like generally I know what FreeType does, but I don't know how font rendering works, so I don't even know where to start searching for the error. So I decided to start implementing some more OpenGL stuff that should be relatively simple. So the next step for me, I guess, is to render a cube, which is in 3D. I know, yes, big surprise. I'm trying to render a cube, which will require me to add depth testing, which currently isn't available. So yeah, after that I might do blend modes or whatever comes to mind. I have no idea what's wrong, but it looks funny. Another wild bug appeared. When it comes to depth testing, I noticed that I can just implement face culling, which in the case of a cube would do the exact same thing and would be more performant. But in general, I'll have to fix this first and I can then work on depth testing. I just realized that since I'm rendering quads, they should be made up of two triangles which share two vertices. And in my case, I have two completely separate triangles. I'm not sure what's going on here. I think I see what is happening here. It seems like the W component does not get cleared when I'm drawing multiple triangles in a single GL draw arrays, which, yeah, let's fix that. So that took an embarrassingly long amount of time. Okay, let's render the whole cube now. Cool, so that works. It takes 30 milliseconds, that is another issue. But generally, that works fine now. Let's actually turn off face culling. So this is now 70 milliseconds. And as you can see, this is the main issue that should be fixable with depth testing. Triangles being overlapped just by the order in which they're drawn. So this is where I'm gonna stop for today. I think I'll finish this tomorrow. I'll add depth testing, stencil testing, and blend modes. I think that will be all. It is a bit of a shame that I cannot get FreeType to work. As I said, I don't know nearly enough about FreeType to go and debug what is happening 10 layers deep in the code. And I don't plan to spend hours and hours debugging that. So maybe in the future, I don't know. But yeah, in the end, I successfully got FreeType to work as well as blend modes. You can see both of them in this example here. So what was the issue with FreeType? Well, honestly, I don't know. Before I got FreeType to work, I actually ported my game The Miner, which is a pixel art game without fonts. Therefore, it needs barely any RAM for textures, and there I found a whole bunch of rendering bugs. After fixing them, I decided, why not, let's try to test if FreeType works now, and the answer is yes. And now, the final thing to do is to port Chain Reaction 2. And after a few hours of work, a lot of downsampling and removing text outlines because for some reason they take up almost a megabyte of RAM, which is too much to properly fit other assets. Here it is, running in a very reasonable 2 frames per second. Much more than my initial goal of 0.016 frames per second. So that is all from me. I've uploaded my SFML ESP32 branch and my half-finished software OpenGL ES renderer over on GitHub. I've learned quite a lot here and equally had a lot of fun. I hope you at least found this a little bit interesting, though I am aware that there are many programming terms I've used not a lot of people will understand. Anyways, that is all from me. Thanks for watching, and until the next one.